Okay, hello guys. This is the second video from my video series which I'll be making on the 9th standard Maharashtra State Board syllabus. Today we'll be looking at the topic understanding matter. Now the topics that are or the subsections that are included in this topic basically tell you how does matter come together. That is, whenever different states of matter come together, how do they interact. So I have also mentioned here, just a second. So as I have mentioned here, basically this topic is about how does matter come together. Okay, so we'll begin with the topic. Yes, this is a very important basic, what can you say, this is very important basic knowledge that anybody must have, that if you take anything, it can be divided into very small pieces. For example, you can crush chalk to very small pieces, and those small pieces again consist of many small pieces. Similarly, you can see here that anything, as a table, glass of milk or the milk in it, everything is made up of these small tiny particles. So if you just zoom any kind of mass or anything, any substance, then you can see that it is made up of these small tiny particles. Now these may be molecules, atoms, or aggregation of atoms and molecules. Okay, so when we talk about particles, molecules and atoms, another important concept related to these is compounds. What are compounds? Compounds are chemical substances. That means that when two basic elements are the very basic part of matter. Everything is made up of different elements. When different elements come together, they make up something or some substance. Similarly, in a compound, these basic elements such as hydrogen, oxygen, when they come together chemically, that is, they exchange their electrons. I hope you know that every element or every atom of an element has electrons revolving around a centrally placed nucleus. Okay, so you can see these are all electrons revolving in a oxygen atom. These electrons from oxygen atom are exchanged with electrons from some other elements. For example, here we have considered hydrogen. So electrons from oxygen atom are exchanged or shared with this hydrogen atom, and so these two atoms combine together to form a molecule. Now for example, consider, now this is an H2O molecule. Okay, so this is water molecule. So when one oxygen atom and two hydrogen atom come together, they share their electrons or they exchange their electrons, they form chemical bonds and form a water molecule. So if you take some water and you with a microscope zoom into it at very high magnification, and what you will see is these water molecules. But in practically, you cannot zoom or magnify any substance enough so that you can see its constituent molecules. Okay, so we'll move to the next part. Yes, mixtures. Mixtures are another important part, or is another important way in which matter comes together. Mixture is a combination of compounds. Okay, so mixture are not chemical substances, they are made from physical processes. While compounds are made from chemical processes, mixtures are made from physical processes. Okay, so it is very simple. And now mixtures are of two types: heterogeneous mixture and homogeneous mixtures. Now homogeneous mixtures have homogeneous mixtures. In homogeneous mixtures, if you consider one part or a small part of the entire mixture and you compare it with other small part of the entire mixture, then you can see that the different components that are present in the mixture are in the same ratio, proportion, or in the same amount as in when you compare these two specific parts of a mixture. For example, consider that this is a beaker and we have water in it. Okay, so this is a beaker containing water. Now what you do is add some salt into this. Okay, so these are salt particles, and we add some salt into this and dissolve it, okay, in this water. Now if you take out this small part of water and observe it or magnify it under a microscope, and again you take this small part of water and again examine it under a microscope at very high magnification, then what you will see is that there is a specific amount of salt molecules present for every specific amount of water molecules. For example, if you take out 2000 water molecules from in here, then what you will find is if there are 10 salt molecules with these 1000 water molecules, and if you take out 2000 water molecules from this part, then you will find that there are 20 salt molecules for 2000 water molecules. So basically you can say that for every 100 water molecule there is a salt molecule, and this ratio, that is 1:100 ratio, 1:100 ratio will remain constant throughout the mixture. So if you take any part of this mixture and examine it, you will find that for every 100 molecules of water there is a single molecule of salt or NaCl. Okay, so these are homogeneous mixtures. I hope you get the idea. The other part is heterogeneous mixture. Heterogeneous mixtures are just opposite to that of homogeneous mixtures. In heterogeneous mixture, the components of the mixture are not in a specific proportion, or they are not equally divided throughout the mixture. In homogeneous mixture, the salt is equally divided or homogeneously or uniformly divided throughout the entire water. However, in a heterogeneous mixture, for example soil, in soil there is not uniform distribution or homogeneous distribution of other particulate matter such as stones throughout the soil. Okay, so heterogeneous mixture, there is no equal, uniform, homogeneous distribution of components of the mixture, while in homogeneous mixture there is a homogeneous, uniform distribution of the components of the mixture. Okay, now yes, this is another important part. This is the different types of mixtures. Actually different types of solutions or liquid based mixtures. Okay, so a true solution, the best example of a true solution is a salt solution or a sugar solution. That means if you dissolve salt or sugar into water, then what you'll get is a true solution. Now the properties of true solution are that a true solution just looks like water. Okay, if you dissolve some salt into water, you find that it just looks the same. It just looks, the water just remains, the visibility through the water is same irrespective whether it contains salt or it doesn't contain salt. So what is the basic thing in this is that in a true solution, the salt particles or the sugar particles, they get divided into very, very small particles, so that our naked eyes cannot see those particles in the water. Then the next is colloidal solution. Colloidal solutions are solutions in which the particulate size is a bit bigger than true solutions. Okay, suspensions. The best example of a suspension is when you mix mud in water, what you'll get is a suspension. Okay, in suspensions the particulate size is very large, and a very remarkable property of suspension is that whenever you pass light through a suspension, you can make out the path of the light. This is also called as Tyndall effect. You will be introduced to the Tyndall effect maybe in this standard or in 11th standard, but it is a very particular property of suspensions. I have got a very good image to explain you what are true solutions, colloidal solutions and suspension. Now this is a true solution, this is a colloidal solution, colloid, and this is a suspension. Now you can see here that you can see these white patches throughout the water. These are the particulate matter that are mixed into the water. In colloidal solutions they are not visible, and in a true solution also they are not visible. But there are but colloids and solutions possess very different physical properties, and therefore they are classified. But they cannot be classified easily with the help of their visible, or with the help of their with the help of their properties in respect to visibility. Okay, so you cannot distinguish these two things just by looking at them, but when you check their or calculate their physical properties, you will find that you can easily determine which is a solution and which is a colloid. However, in the case of a suspension, you can see the particulate matter suspended in the water, so that you can easily make out that it is a suspension. Now, another important topic in this is separating the components of a mixture. Now there are various physical processes as well as chemical processes which can be used to separate the components of a mixture. For example, if you dissolve salt in water and you want to again separate these two components, then what you do is just boil the water evaporates away and leaves behind the salt. So this is a physical process with the help of which you can separate the components of a mixture. Now there are various physical processes and chemical processes involved with separation of mixtures, depending upon what does the mixture consist of. So you do not need to study those things in depth for your current syllabus. So that's it. I think I have gone through all the points and I think you have understood them. So thank you. Thanks for watching. And please subscribe and comment any question or any query or any suggestion you have about these videos. Any improvements you want in these videos, please feel free to comment them in the comment section below. Thank you.